We are now heading into our next session. It's a longer session on code extensibility with SAP's very own Nick and Vitaly, who have prepared an overview session and also a live demo, which is always much appreciated. So help me welcome both of them to the stage.
Yeah, hello. My name is Nick. That's Vitaly. He did the heavy lifting. He's the main developer of the thing. What is it all about today? It's the new plugin that we have for CAP called CDS-Oyster. It's available on NPM as of last Friday. It's an alpha release. So whoever downloads it, you're a crash test dummy. You're helping us soften the rough edges and find any bugs or holes or whatsoever. But since we have a link on the slides, you're encouraged to go look there, install it, play around. There is a README helping you set up, and also a tutorial that is going to be available soon. What is CDS-Oyster? So no worries, the slides are only going to be short. We are going to show a demo. We are trying to have a demo to slide ratio of 2:1. Hope we go over it. So CDS-Oyster is a CAP plugin. It's hopefully a very secure environment to execute untrusted custom code. It's meant for multi-tenancy, multi-tenant SaaS deployment, because to be honest, there is no sense in creating in-app extensibility for a single tenant or your own managed application. You can write your own code, deploy it, whatsoever. But in multi-tenant applications, you do not trust what the customer extension developers do. So you want to encapsulate the stuff, you want to execute it as securely as possible, and also with the least amount of potential damage that is going to be done by not so talented application developers. It's based on a component also developed at SAP called Oyster Runtime or Oyster SDK, which is an umbrella or a wrapper for WebAssembly. So everything runs inside a WASM module. Rust is a runtime. We are allowing JavaScript using Java on top of it. And we think that WASM is a very secure environment. And we think the trade-off between security and performance is best in WASM. It's also completely integrated into CAP. So for the extension developer, it feels like they are developing a normal CAP application. So the code looks the same as a standard CAP Node.js event handler. It's also completely embedded into MTX. That means the extension code is part of a normal CAP extension project. You do a CDS add extension or CDS init and extend your application. You do your CDS pull. All of these things work. You write your handlers, you write your custom code, you test it locally, you also debug it locally, and then you deploy the code together with the rest of the extension to MTX, and the plumbing is done there. Code is sanitized, code is searched for bad constructs, and then you deploy your extension to production when you're happy with it, and we do all the rest. So the big picture is when you listen to Daniel at CAP, everything is an event. So the central part of the CAP runtime is an event loop, which is, regardless of it's a service call, it's a query, it's a database, it's a transaction, whatsoever, everything is an event. And we are plugging into the native CAP event loop, and we are adding the capability of stopping the CAP event loop for a short time and creating an environment that allows for execution of custom code. That code is never physically executed. There is no deployment of code wherever. There is no upload to a file system or whatsoever. Everything is embedded as extension, and it's also part of the extension season. So it's part of a model, never physically present somewhere on the machine. The code is handed over to Oyster, to a WebAssembly executable, runs there with a couple of cool features that you'll see later on. And then we give control back to CAP, and everything happens in the normal way. So with that said, we did invest a lot of time in security. So we tried to find the best possible execution environment. We've played around with worker threads, with V8 isolates and similar things, but WebAssembly is really completely decoupled. It's completely stateless. It's an industry standard component, hardened and proved. A lot of big customers, also some of our competitors are using it very successfully. I won't name them, but we know there are stuff in there. We enforce resource quotas, so we are managing a quite tight regimen on how many CPU time, how many memory is allowed, how many execution levels and similar things. So we are allow for the tight management of these things. As mentioned, no customer code is ever going to touch a CAP server itself. It's only a string which is passed around in a variable and passed over to WebAssembly for execution. Also, the API that the extension developer has is very limited. It looks like CAP, but it's only a subset. You can't do everything that you're used from CAP. You can do queries, you can select, you can emit events, call actions, and similar things, but you can't go into the request object and do all the nifty stuff that you are used to do. You have rec subject, you have rec target, but only as strings and similar things. No model access, no manipulating around, no access to the database itself, never. No access to the transaction. You're asking the CAP runtime to execute a query for you. And the CAP runtime is doing it the best it wants to do. And sometimes it won't allow you to do it because, for example, authorizations are enforced and similar things. So we are controlling a lot of different things. No shared context, no context at all. It's really, you are in a local environment, you have no access to, there is no tenant inside the developer environment, no concept of tenants, nothing. It's like developing a local application. We also allow or integrate with the allow and deny list of MTX. So you can very finely grained control what is extensible, where you can put code, where you can't put code. We also do some code sanitation. As said, WASM itself is already our first frontline defense. Code sanitation is the next. The limited API is the next thing. And then also the completely stateless nature. So every time in the event loop, some custom code should be executed. The machinery is turned on. Everything is done from scratch. Everything is thrown away afterwards. So the WASM executables or WASM binaries live only for microseconds, usually. We also invested a lot of time in making error handling as graceful as possible. You can't throw errors inside the code. None of these things. So you can only use rec reject, rec error, rec messages, the best practices of CAP, and only them. We also monitor extensions that, for example, exceed resource limits. We stop them, and we also put them in quarantine. So bad extensions aren't executed often, only once or twice, and then they cannot be used, for example, for denial of service attacks. Because if you upload intentionally a bad extension and then have a lot of calls on that intentionally, you could put down a server. We are not having these. The same would be for endless loops and unlimited sandbox chaining, because we could potentially, one sandbox could create another instance of a sandbox and create an endless loop. We are also monitoring that and stopping that. That's enough talking. Vitaly is taking over for the interesting part.
So, hello everyone, let's see the demo. So for the demo, we prepared a very simple extension project based on the incident sample. So in the incident sample, you basically have two entities, customers and incidents, and customers can create incidents. For our extension, we did two additional concepts. So let me open the extension file. The first one, we added additional fields to customers called status. And the idea is it basically can be gold, silver, or bronze. And another concept we introduced in our extension is two additional actions, promote incident and promote customer. So promote incident is a bound action where you select one incident and promote its priority to high. And promote customer is an action bound to a collection of incidents because you not only promote the customer to the gold status, but you also promote all his incidents to high priority. And that's basically it in the extension. The rest here is mostly UI annotations and some additional projections. And before we dive into the extension handlers, let me quickly show you how it runs. So I can start my extension locally as a usual CAP project, and it will immediately run with Oyster framework. So if I open package.json, you see there's an Oyster framework configured with, oops, this was playing around. The Oyster framework is configured with max times max memory, and the Oyster framework will also run locally on my computer now. And let's see how it works. So basically, I can say CDS watch and start my project locally. And this is a Fiori preview UI, which is also generated locally. Let me refresh it. It runs. And you see here, from our extension, we have an additional column called customer status, which is, as promised, gold, silver, or bronze. And we see here above two additional actions, promote customer and promote incident. Promote incident is a bound action. So for this one, we should select incident instance. Let's take this one. And if I click to promote incident now, you see the urgency is updated to high. And the logic for it run in the Oyster Sandbox locally. I hope also promote customer is running. So for this one, I should select the customer. Let's take the Stormy Weathers and promote. And you see now not only his status is promoted to gold, but also all related incidents are promoted to high urgency. Let's now see how it's implemented. For extension handlers, we need a special directory, which is service name in this case. And there we need a subdirectory for entity name. In this case, it's incidents. And in this directory, we have all extension handlers in the notation registration minus event name. And this is how extension handlers can be written. So let's consider those two which we executed. For the bound action, we here just take the rec.subject, which points to exactly the incident we selected in the UI, and we update exactly this incident saying your urgency code will be high. And promote customer is a bit more complex. So here we update customers and we update the related incidents. And you see for updating the customer, we are taking the parameter which were provided in this pop-up dialog. And the same is true for incidents. Two special things I want to show here. First one is, as you see here, we did the update using this.update. This, in this context, is a service. So it means we used the CRUD API of the service. And in another handler, we did it directly from the query language. So both possibilities are available in the extension handler, and they are more or less the same. And another special thing I want to show you in this updating of incident, we also have additional condition here saying the status code is not closed. As actually doesn't make much sense to update the closed incident. And, but what I want to show that this additional condition is written in the object notation, and the whole where condition is also written in the object notation. For security reasons, we only allow object notation in the query language to write your database queries. So I'll go back to the demo. Looks fine, but what if I want to create a new incident? Okay, I will give some abstract name for this incident. And I select the Stormy Waters, which we newly promoted to Gold customer. But in his incident, I want to say low priority. This is a kind of contradiction to what we want to achieve. And there is currently no action to fix it. But we have the possibility. We can, as also in CAP, write CRUD handlers before and after, create, read, update, delete. Everything is possible. And maybe you already have seen those two custom handlers, before create and before update. And in this case, before create will help us. So we basically say we take the customer, look for the status of the customer, and if the status is gold, we automatically update the urgency of the incident to high. What is special here, if you compare this to promote customer, you can notice that here we just use the names, hard-coded the names. And in this handler, we are using a customer object obtained from the service. So this also works in the Oyster framework in extension handlers. And let's see if it still works. Yes, so I saved, and it's automatically updated urgency to high. I can try to do another trick and try to update this incident and still assign low priority to it. So what will happen in this case? In this case, we have our before update handler, which maybe hopefully do something reasonable. And in this case, it again gets the customers and checking the status of customer and the urgency. If it doesn't match, it just rejects the request. This reject is actually the only possibility for extension developer to break the execution and throw an error, because for security reasons, the standard JavaScript throw is not allowed here. So we want to control the thrown exceptions. Let's see if this really occurs. Save. Yes. So it says me no, it's not possible. You should take high priority for this incident. Okay, I agree. And now I can save it. So these are basically the custom handlers. They were running in the Oyster framework. Now the question maybe of each developer is how can I debug it? For this, we did following option. I can go back to my package.json and say I'm not using Oyster anymore. I want to use our debug engine. I will stop it here and open in my debug terminal. I start again the application locally. So what's happening now? I go to some handler. There's already a breakpoint. And no. If I refresh now the UI, you will see all our changes are gone because I'm using the in-memory database. So after I restarted the application in debug mode, everything is lost. But it's fine because in this case, we now can repeat our action and can promote the Stormy Waters again. And we are there. So we can now debug our extension handler. So let's take a look at it. This object. As I mentioned, this is a service. And if you know by heart how the service looks like in the standard CAP handler, you will notice that here you see much, much less options. You basically see a few database accesses like create and delete. You can emit event, you can require for entities, and basically that's it. And the same is true also for the input request object. It's also much, much less compared to the original rec object, which you can see in the standard CAP handler. And this is exactly, those two objects are exactly what is seen in the Oyster framework. So basically in this debug mode, you see exactly what later the Oyster framework can see. So it's also kind of security check. You can take a look at everything here. I will do step over to show that debugger really runs. And I can now switch back to Oyster. And restart. Refresh the UI. It's from scratch again because of in-memory. And if I do promote customer now, Stormy Weathers, then it just runs without stopping in the debugger. But we still have one trick here. I think I prepared it here. You still can write console log. So even from Oyster, through callback, the console log is still possible. So kind of debugging still can be done. If you want to see it, maybe I can select one incident and promote it. High, you see it's high now. Let's go back, and this is our console output here. This trick is only running if you start your application locally. Otherwise, this is not possible. So if you deploy your application, start a real multi-tenancy application, or use another language like Java, this stops working. It's only for local execution. One thing maybe I still want to mention before update. I was quite quick here. I have shown you the reject, but there is a strange line here too. What's happening? This is just a workaround. This is not a solution. I just quickly did it to escape one problem. And the problem is the following. If somebody expects before update is running, that maybe he thinks, okay, I click in my UI here on update some item, and my before update will run. Yes, but this is not the only case. Consider our promote customer. Here we update the incidents through the service. And updating it through the service means all handlers before, after, everything will be involved. This is again done for security reasons because usually all authorization, authentication, all security handlers are the before handlers running at the beginning, and we want to keep them, of course. What does it mean? It means also our before update handler, which we have written here, also will run in this case. So this meant maybe a bit unexpected for somebody who just implemented those extension handlers. And this is especially dangerous if you write read handler. So for read handlers are basically involved everywhere. You can involve read handler from your UI. You can involve read handler from service call like this, but they are also automatically involved, for example, also here in the update. So if you call update handler from the service, that at the end, also the read request will be done to ensure what is actually updated in the database. And then unexpectedly, maybe for you, the read handler will also run here. And this is potentially dangerous because it can easily build kind of circular dependencies and loops by the execution. And yes, sandbox is secure, but what's happening if you, in the update, start your before update handler? For this before update handler, a new sandbox will be created. So you now have already 2 sandboxes. If before update handler executes again another code, for this another code, the 3rd sandbox will be created. And if you have circular dependency, you can easily consume all your memory with sandboxes. And we want to prevent this. Of course, we have techniques, as Nick already mentioned. We control the loops, and as soon as we find out here's a loop during the execution, we stop it and we put the extension to the content. So it's blocked. And then the developer should do some changes, fix it, and only after the extension is deployed again, we switched it on and say, okay, let's give it a try until the next loops, and then we block it again. So this is why this strange line here occurs. This was just my workaround to say I only want to apply this in one situation and all other are blocked. This is not the best solution, but it just was a demo. So now we have seen all handlers, we debugged them. We are now back to Oyster locally. We've seen we still can do console log. So what's missing? The last part of my demo. Now I want to start the application. I will start it locally, just to be sure it runs anyway. So I will start locally my incident application. And I start also sidecar. So what I can do now, I can say in my extension project, I want to push this extension now to the main application app. It's built, and it's pushed, and it's activated. So it's there. And now I can go to UI back, and instead of this preview, I will open my second tab where I prepared the application UI. It mostly looks the same as in case of the preview. And it mostly has the same functionality, but now I'm not running my extension. I'm really running my incident app and in multi-tenancy mode, and the extension is deployed to a single tenant. And that was just update our stormy weathers again and see that he is cold now with high incidents. And with that, I finish my demo and hand over back to Nick.
So a couple of key points that I hope you recognized the code of event handlers. It looks really like normal CAP event handlers. It's a module export, it's a function name, but inside that, it looks exactly like that. And we did a lot of heavy lifting in order to make that, because inside the sandbox, inside WASM, there is no CAP. There is also no CDS compiler. And we did not want to put the CDS compiler over model or serialize everything to and from. So it's really just a minimum umbrella. We created a request object and similar things to look like that. And because the CAP mindset is, no matter how complex a problem it is, we want to make the solution as simple to use. And application developers or extension developers should be able to go to Capire and look how to write event handlers, to write the custom extensions also. And you've seen we can debug, it's limited, but it works. But once you deploy the stuff, there is no way to debug that. You can't debug code that is running in Rust, trying to emulate JavaScript, trying to emulate an existing CAP runtime which does not exist, trying to emulate a compiler which doesn't exist. So now what? This is alpha, released on Friday. We encourage you, we ask you, go if you're interested, try it, play around with it, give us feedback, very important. We need your feedback, we need your use cases. We need to see what is missing, what you additionally need, what is unnecessary, what is not intuitive. We plan on really releasing this year. That's an intention, no promise. And as a roadmap, yes, we need good developer documentation. We need to take a look at performance. It looks good. Performance really looks good. We are astonished how well it works, but you can always optimize. Also, you've seen, for example, some of the convenience methods in the debugger, like exists. You can really just say if this dot exists. So these convenience methods, we need to know from you what you need, what is necessary. All these callbacks that are necessary, also perhaps callbacks to external systems, similar things. And also we need you to poke holes, to try and intentionally crash the thing, to tell us we did something wrong. And I already showed the picture, the big picture, now the even bigger picture. Although it looks simple, we really invested a lot of engineering power here. So there was a lot of thinking of a project. We showed a similar, or the predecessor of this project 2 years ago on reCAP, using VM2 and V8 isolates. Now it's WASM. And now we are also happy with how secure it looks. But the box that you see, we really invested a lot that there is no code. The CAP runtime does not get in touch with the executable or customer code, except it's a string in a variable. We attach, so when you push an extension, the code is managed by MTX. It's parsing the code, it's completely sanitizing the code and setting it together from scratch again, and it's attaching that as an annotation to the model. And then it gets passed around for each tenant with the tenant model and the CDS model provider from MTX. Then when we stop execution in a request, we really copy the request object, and we only take the serializable parts and the parts that we think are necessary and nothing else. So we try to minimize the amount of serialized data. We are passing it over to Oyster, which is giving us a WASM binary with a framework with the CAP lookalike in it that we also created. And then we have the rec object, the callbacks, and all of the other things inside there. And every time you use a callback like this.select or await select or also call an action, what we do is we serialize that stuff. We create a season or a CQN string, and we give it to the CAP runtime and politely ask, would you like to execute that for us? And only if a CAP runtime says, yes, I recognize this is an application service entity and not a database entity. You are authorized, the user of a request is authorized to do that stuff. Then that query, for example, is executed, and only then. And the result is also passed back respecting authorizations and also executing all other event handlers that are registered, also the normal application event handlers that are registered to the application service. And you can also, inside WASM callbacks, you can emit events and you can also call actions. And these actions could also be custom actions from yourself. So you could create a Oyster instance or a WASM instance with your custom code, which is triggering another WASM instance, which is triggering another WASM instance. And that chain can get quite long, and it performs surprisingly well. We are very happy with the result. And as a final remark, these actions are the premier way to do custom extensibility. Normally, you would say, I don't allow extension developers anything to do, but you would revert back to the body concept. So you have your application code, and in your application code, at some point in time, you execute an action, and it's a no-op action. There is no implementation. You document that and say, this is the name of the action. It's body underscore validate underscore customer. And then the customer, the extension developer, has a fixed type, has a fixed input, has a fixed output. It would, the customer would do the processing there, perhaps with your own handwritten documentation, and deploy that in the sandbox and nothing else. So that would be the first start, is emulate something like bodies, and we tested that works like a charm. And we also plan on releasing, together with the colleagues from subscription billing at SAP, a extension box which does exactly that and provides a UI and lifecycle management for these body style extension points. That is also something, stay tuned for, I think also this year. And some shameless plugs. We have a workshop where you'll be creating that example plus some additional cool stuff and also play around with bodies and similar things. 10 to 2 in the orange room. We are also in the extensibility expert corner from 4 to 5, where we'll also be joined by Eki from MTX and answer all extensibility questions to our knowledge. And now we have 5 minutes left for Q&A.
Hi. I have 2 questions. First one is for the event handlers. Is TypeScript supported?
No.
Darn. Yeah. Second question is, in the event handler you mentioned if something goes wrong you have to reject it. But would it still be possible if I, for instance, go to a separate class, do the processing there, throw an error and then reject again in the event handler? Is that possible, or should it always be a reject?
So like rec error.
You can also create an error. You can also do rec warning, rec message, whatsoever. So the normal best practice way of CAP is possible. So you can create an error, and other event handlers are also doing their stuff. For example, perhaps emitting an event, even for example, audit logging. Audit logging should also be done for unsuccessful events. So you would not do a rec reject, you would do a rec error. So the chain completes, and then after everything is done, then you look at the result. If there is an error, then the rec reject is created as the final step. So there are multiple possibilities, but you can also create warnings, infos, stuff for, I don't know, Fiori elements, UIs, where you say you need to fill in that thing, and the red box appears. All of these things is possible.
So my point was only if you want to break the execution, then the direct reject is the only possibility. But of course, you can do something else.
Yeah, makes sense. Thanks for the great session.
Thank you. When you deploy, you can already do that for Cloud Foundry. Is there any requirement for the memory size you should give your instance?
Actually, no. The thing is, on Cloud Foundry, your Node.js runtime is, one of our team members is, it's basically, Node.js is running on toasters, basically, in Cloud Foundry. It's very small. But there is 4 CPUs, right? And the memory is, I don't know, half a gig or something like that.
Yeah, you can configure it, of course, to 8 gig or 16.
Yeah. But basically, in the ideal case, WASM runs in separate threads. So in the ideal case, you have 3 threads running the extensions and 1 thread running the CAP event loop. So that's the best setup. And that exactly works well on Cloud Foundry. And for memory, it's basically, we need your experience and your playing around with it for us to know how to create the default. We don't know what the defaults are going to be.
And can you set limits, like how big like a user extension is, or?
Yes.
Okay, that's good.
So there is a maximum memory size per extension, but also Oyster itself is growing and getting a lot of different. So there is a throttling component being developed for Oyster to, for example, circumvent or prevent the denial of service attacks. So Oyster is doing some of the lifting for us too.
One more question?
One more question, yes, please.
Okay, but don't forget, we have another session of
Yes.
yoga.
Half a minute. Oh, okay. Sorry.
Thanks for that session. Good to see that capability coming up. I was just curious, you mentioned obviously Oyster is geared toward multi-tenant SaaS applications, and for a number of years now in the CAPIA documentation there has been already a framework for SaaS extensibility and for the customer to extend multi-tenant applications. So I was just curious how Oyster fits into what's already existing in that framework that's documented in CAPIA.
It's a very short answer. It's completely integrated. So we are relying on MTX, on the multi-tenancy of MTX, and we completely integrate there and do nothing on top of that. Everything is an extension project, like what the customer knows from. Everything remains the same.
So I think this slide was about, so you can write model, data extension, and business logic is just one simple part there.
Okay, so this kind of fits into that existing extensibility framework? Okay.
Yes.
Thank you.
Okay. Enjoy your yoga session. Come on. And
Thank you.
join our workshop. If you have questions, we'll be in the expert corner at 4, where you can ask much more.